Back students, I hope lesson 1 was of quite good help for you. It was an introductory lesson, therefore we went very slow and we tried to drill into the basics, but today we will catch up with some pace, and in today's lesson we will try to connect what we studied yesterday. If you can revise with me, yesterday we concluded and we established for sure that it is the electric charge, the fundamental property which is responsible for electric force. Out of all these things, you remember this thing, that it is charge which is the fundamental property which is responsible for electric force. Now let us start today's lesson with another established fact, that matter is made up of atoms. I think you can take down notes of these graphical representations. Matter is made up of atoms, and you know by this time that both matter and atoms, they both are neutral. By neutral, again re-emphasizing, you know that atom is made up of electrons, protons and neutrons. Protons and neutrons form the part of nucleons inside the nucleus, nothing to do right now with them. Now electrons, it is basically only the transfer of electrons which gives rise to the concept of an atom being charged into a positive ion or being charged into a negative ion. So the deficit of electrons or excess of electrons, this leads to the presence of charge. You should take down these things. I tell you again and again, deficits of electrons or excess of electrons leads to the presence of charge. So our, what you can say, key factor upon which we are meditating, we are trying to, what you can say, have a microscopic view into the concept is charge. Presently this is our key thing. So charge is responsible for electric force, already studied. Now charge is a scalar quantity. Right now, need to agree with me. Charge is a scalar quantity. Its dimensional formula is ampere time. Ampere for current and time for, that is the fundamental unit of time. Units, as we know, it has SI units and CGS units. The SI unit of charge is coulomb and CGS unit can be expressed as ESU. You can write down the full form in your notes. ESU stands for electrostatic unit, and the other unit is EMU, which is electromagnetic unit. Now ESU, 1 coulomb, C, capital C, stands for the unit of charge, which is C. Here you can say coulomb is represented by capital C. 1 coulomb is equal to 3 into 10 to power 9 ESU. What is ESU? Electrostatic unit. Then another CGS unit, EMU, which is 10 coulombs, capital C, remember, represents coulombs, is equal to 3 into 10 to power 10 ESU, electrostatic unit, and which is again equal to 1 EMU.
Then
So after studying the SI units, that is coulomb, CGS units, that is ESU and EMU, we come to the different states in which a charge can exist. Now students, little tip, this flow chart of notes are going to help you a lot if you take it down properly, both for studying as well as for revising. And they will be of course a great help during your exams when you would like to have quick and short revision of important points. So try to note the things the way I am trying to give you. So a charge can exist in these three different states. Number one, charge can be at rest. If a charge is at rest, it constitutes electrostatic field. Again, this word rest you will find here in the word itself. A charge can move with drift velocity. This term we will study in the coming chapters, but presently you can take it as constant velocity or uniform velocity. So a charge, when it is moving with uniform velocity or drift velocity, it constitutes electric current. Of course, this is going to be a chapter. Your third chapter of physics is electric current. Then if the charge is in acceleration mode, acceleration is rate of change of velocity. If a charge is continuously changing its velocity, or you can say magnitude of speed or direction continuously, you can say that the charge is in a state of acceleration. And if a charge is in a state of acceleration, you say that it produces electromagnetic waves, EM waves, electromagnetic waves. So charges in acceleration, EM waves, charges with uniform velocity constitute electric current, which you know, the light and everything is responsible. Then we have charges at rest, they constitute electrostatic field. In this present chapter, we are concentrating on this particular aspect of charge, that is charge at rest constitutes electrostatic field. In this chapter, we will be, in this unit of course, we will be concentrated on electrostatic field. Now, charges we will study in these different headings and of course forthcoming subheadings. These are the different headings under which we will study this one word charge. As I told you, we are going to have a microscopic view of this word charge. So we will be studying about polarity of charge, properties of charges, how to measure charge, and what are the different methods of charging. Polarity, you can write down, it is the property which helps in differentiating, I have written in short, property which helps in differentiating between charges. This is polarity. Now, according to polarity, we have positive charge. I hope you are able to see it clearly. We can have negative charge, or we can have neutral, no charge or zero charge. Positive charge, by this time you are in class 12, come on, I believe you know that positive charge is the deficit of electrons, when we have taken some electrons out of an atom or any body. Negative charge is when we have added some electrons to an atom or to a particular body. Third state, neutral, means equal number of electrons and equal number of protons makes the body or the atom perfectly balanced in charges, net charge 0. You can write here Q net equal to 0. So these are the various states in which a charge can exist, and these are the different topics or headings which we are going to cover in the forthcoming lectures. So children, it's my request, note the things systematically and make sure that you are subscribing for further notifications. For if you want to get further notifications of the forthcoming lessons which are very systematic and which are very much aligned in the CBSE board pattern, you must subscribe so that you get time to time notifications of these things. So the different heads I told you under which we will be covering up charges, polarity, yes, repeat with me, polarity, then properties of charges, methods of charging and measurement of charges. So let's catch up and pick up the first head, which is properties of charges. Polarities I've already given to you. So we will be starting with properties of charges. The first property of charge, you can, I'm telling you repeatedly, take the notes. These notes are highly systematic and they will be of great help to you. So the first property is additivity of charges. It is additivity of charges. It is total charge on an extended body is the algebraic sum of charges in different regions of the body. I am repeating, total charge on an extended body is the algebraic sum of charges in different regions of the body. In one simple way, we can state it as charges are added like real numbers. It's one and the same thing. Charges are purely added like real numbers. So you can keep it in mind. And I just want to give a little tip over here that very rarely in CBSE question papers we find directly to state the properties of charges. In the past 15-16 years, I've hardly seen any question which is directly asking to quote the properties. But 100% you will find in the entire paper application of any of the properties which we are studying. That means it comes under the you can say typology of application type of questions. Once you are very clear with the fundamentals of the particular property, you will be asked to apply it maybe in numericals or reasoning based questions, or in different aspects where you are supposed to apply what you know. So just let us take an example. We have taken a coordinate system, x-axis, y-axis and z-axis. Here I have got two charges, QA, I have named it QA. Magnitude of charge is 2.5 into 10 to the power minus 7 coulombs. And QB is minus 2.5 into 10 to the power minus 7 coulombs. So you can, from the very, what you can say, look, you can make out that QA and QB, magnitude wise they are same. The only difference is with this negative sign. The location, or you can say position, is for QB it is 0, means x coordinate is 0, y coordinate is 0, and of course z coordinate is 15 units. You can say, I have not mentioned any of the units, but it's 15 units. Then the second charge QA is having 0x coordinate, 0y coordinate and minus 15 as z coordinate. Now if I ask you what is the net charge over this line, or what is the linear charge on this system, the obvious answer on the application of this concept is charges are added like real numbers. So plus 2.5 minus 2.5, the answer comes out to be 0. If I take a body at random, you can see I have taken any body. I have got charge Q1 1 microcoulomb. I am introducing one term to you, that is micro, that is 10 to the power minus 6 coulombs. Just keep it in mind, smaller units of charges. Q1 1 microcoulomb, Q2 2 microcoulombs, Q3 minus 4, Q4 minus 1 and so on. I have taken at random some charges, and if I ask you to find the net charge, then what you are going to do is 2 microcoulombs plus 1, 3 microcoulombs, then here it is minus 5 microcoulombs. So what I am doing, plus 3 microcoulombs and minus 5 microcoulombs. The answer comes out to be minus 2 microcoulombs. This is how we are going to apply this concept of additivity of charges in forthcoming topics when we will be asked to find the net electric field or flux. After finding out the net charge, this concept will be applied. So I hope you got it. The very first property of charge, additivity of charges, we have to add the charges like real numbers. I hope you got it. So I hope you are clear with the first property, that is, just now we have seen that additivity of charges. Now we come to the second property of charge, which is conservation of electric charge. Now by this time students, as you are students of class 12, this word conservation is quite a familiar word to you. You have studied so many laws regarding conservation, like conservation of mass, conservation of energy, conservation of linear momentum, conservation of angular momentum, and you are by this time familiar with this word conservation, where most of the times you are given a term isolated system. In class 11th, if you remember, momentum remains conserved for an isolated system. So drawing parallel, connecting back to the things which you already know, we are establishing the same thing for now electric charge. As you have studied conservation of mass, conservation of linear momentum, conservation of energy, conservation of angular momentum. So we are drawing the parallels and trying to establish conservation of electric charge. You can write down net electric charge. This word net is important. Net electric charge in an isolated system is constant. So there is great significance in physics. In each and every term you have to pay attention, because that is a concept. We will unfold this concept of net as we come into the depth of the topic, or we dive into some numericals where we find the application. I will clarify the concepts. So presently, keep in mind net electric charge in an isolated system. By this time you are familiar with isolated system, the system which is not in interaction with external forces. So net electric charge in an isolated system is constant. This implies that charges can neither be created nor be destroyed. Second thing, this implies that only charges can be transferred. You can neither create charge through any chemical reaction or any kind of reaction. We cannot destroy charges. We can only transfer them. So this implies, the conservation of charge implies these two facts. Now let us look into an example. Our first example is of course a nuclear reaction where we have 92 uranium-238 undergoing alpha decay. This is alpha particle. So 92 uranium-235 undergoing alpha decay, 2 helium-4 plus 90 thorium-234. Here I want to draw your attention to the number of elementary charges before, or I can, it's better if I can write elementary particles, that will be helpful to you. Number of elementary particles before and after decay remains the same. Before decay, the number of elementary particles 92. After decay, the number of elementary particles 2 plus 90, again 92. So the net electric charge is conserved. Second example we are taking for pair production. Why I have chosen this particular example is, in these kind of examples of pair annihilation and pair production, it seems apparently as if charges are being created or charges are being destroyed, but actually it is not so. In a gamma ray photon, it undergoes a decay into electron plus positron. This happens inside the nucleus. This is called pair production. Net charge of a gamma ray photon is 0 before and after the interaction.